So in the previous video, we actually flashed the ESP32C6 board, which I have, and you can like define or set up a config of any ESP32 board and flash the hello world, which is the first program that ESP32 suggests to flash onto the chip, right? And we actually flashed it and showed the monitor. So I was still here, which is basically idf.py minus p and the port ID and the command monitor. And if you see it, I have the ESP board connected and it actually prints hello world. Now we hadn't seen the code of this hello world, so in today's video we'll just go through the main file which contains the code of this. For now, let me just stop the monitor, which is control and closing square bracket, right? So I'll just clear it out. I'll clear it out the another terminal as well. I'll list the directory of hello world, and it actually contains a main folder, and there are a bunch of files which is build cmackeys.txt hello world sga some configs and readme markdown file. So ideally the information of the project or any project, I would say, have should be contained in the markdown files or text files, right? Here I can see one is markdown file here, readme.md, and cmac list.txt. Now cmac list is basically how to build the project. It has the information on how to build the project. If I open that, let me open it, and it contains something which says the following lines of bullet point to be in your project. CMake orders make work correctly. CMake minimum version requires this and include this project.cmake. Trim the build, include the minimum set of components, main and anything depends on IDF site property, minimum build on, and project hello world. I don't understand really what is going on, but like if I look up for CMake list and what is CMake list.txt file, I should be able to get some information. It's basically primary input file for CMake build. So basically any C program that you want to build via CMake, it's the primary file it sees is this txt first, and then other files. Okay, so basically it's a plain text file containing a set of directives and instructions which CMake uses to generate native build systems. Cool. So I think it's just a project build file, instructions given for now. We don't have to worry about it. I'll just again print all the files, and I'll go and open this readme file, and we are here. It has actually opened the file on Visual Studio Code. I have Visual Studio installed on my system. Okay, so let's go through this. So it says the supported targets are this many. I have ESP32C6. You might have any of the other boards. Oh, it supports Linux also. Wow, okay. So generally you will have ESP32 board, but you can have any of the board that are supported here and flash the project. We'll just go through the hello world, which is an example project. starts a free RTOS task to print hello world. So basically what it does is it runs a free RTOS task, which is operating system. Free RTOS is an operating system, by the way, and it runs a task on free RTOS to print hello world. See the README file in the upper level examples for more information about examples. We'll just skip for now and continue in this README file. How to use this example? Follow detailed instruction provided specifically for this example. Select the instructions depending on chip installed on your development board. I have ESP32 C6 installed, so it's basically ESP32 getting started. So I'll have to look at this guide, which is the same as this guide. Example folder contains the project hello world contain one source file in C language, hello world main.c, main folder, and in that hello world main.c. So if we go to the directory, I have this main. If I go into this main folder and list everything, I have hello world main.c file, which is exactly what they have mentioned here. File is located in the folder main ESP editor build using CMake. So project build configuration is contained in CMake list.txt file that provides set of directories and instructions describing project source and targets. Below is a short explanation of remaining files. CMake.list, Python test hello world. It's a Python file. That script is used for automatic testing. We can look at it afterwards. If you want, you can look at it when you get time. But for now, we'll just focus on this C file, which is the main file. readme.md, which is the file which we are currently reading. For more information on structures and content, please refer to section. Okay. Troubleshooting program upload failure. Either connection is not correct. TF monitor and reboot to see if there are any logs. For now, we don't have any problem, so there is nothing to see in the monitor. The baud rate for downloading is 2i. Maybe it's the case of failure if you are trying to upload and it fails. You can change it in menu config, which we have seen. Basically idf.py space menu config. It gives you the menu of the ESP board. Let me just show you that. I CV and sorry, my bad. Just went to the previous directory. I'll just see monitor and okay, it shows the monitor and idf.py menu config should show you the menu, and you can actually go use the arrows to go up into the menu, down into the menu. To see bootloader config, you can go here and bootloader manager. Just go back, serial flash configuration. And you will find the baud rate in this this option. I don't know where the baud rate is, so I'll just go quit for Q for quit, and I will quit. I'll stop this for now, which is control plus closing square brackets, and I'll go back to the readme instructions. For feature, we'll get back to you as soon as possible. Okay, cool. Now since I have read, I will just go to the C file. Just go inside the main folder and I'll open hello.c. And now this is the file which is running inside my board. Okay, so it has bunch of includes and a main function. So for free autos, like generally we run main function right inside any of the C file which it sees, um, and starts the instruction. And for free autos, we have app main which it sees and runs. Okay. So basically, what ESP instruction says is if you put an app main inside a C file, build it and flash it, free autos running inside ESP should be able to see this app main function, and it should run all the instructions that are put inside it. And we have a bunch of includes. I don't know much about this. Includes stdio is an inbuilt C compiler input. In types.h is again one more, which explains or which has the definitions of integer types, different integer types based on the bytes that it stores. Standard IO is for printing and stuff. So if I want to print this, then I'll have to use stdio.h. Same goes for this print, this print, and this print, and this print, and this print. Okay. In types, I'm really not sure about what the definitions are inside that. SDK config, free RTOS, ESP chip info, ESP flash, ESP system. So I don't know much about this includes, but for now we'll just skip that. And actually, let's look at it. Hmm, Wait, for now let's look at this in the next video about every stuff. I'll just go through app main for now. Says print hello world as a variable declaration. Gives this variable. I think it is used to store the information of the chip. This function is used to store it. So most likely the information or the declaration of the header will be inside uh, this header. Then printf some integer unsigned int declaration. Then again printf conditional function to check whether the flash size is null. Then printf again print, then a for loop, printf flush to remove all the output, and then restart. There is a task delay here, which is this. I think it's a macro defined somewhere, most likely in the flash or system, because that macro is not defined here. And 1000 is divided by this period milliseconds, so most likely macro is defined somewhere. So there is one more macro, chip feature EMB flash. There are more macros here. There is one more macro ESP OK. Cool. So I think it's what it's most likely doing is printing hello world, getting the chip info, saving it in this variable, flash size it's saving in this unsigned integer, which is 32-bit, getting all the info from this function, which is most likely inside this include, print in printing some of the features of ESP32, which it got from chip info struct. I think this is a struct because there is a dot keyword used. Not keyword, I would say. It's a, I don't know what it's called. Right? It's basically there is feature inside this chip info which it calls and then compares with chip feature Wi-Fi Bayesian bit. Most likely it's a bit because this is a bitwise operator and this is a macro. So most likely it's defined somewhere. We'll look at it in the next video about this macros where they are situated, like by opening this files. Most likely they will have things which after which it will make sense. This program will make sense actually. Um, if cool, it's again using one more macro, doing bitwise operation with feature and printing something. Again printing. This is one more macro. Or yeah, it it is a string actually because printf takes all the strings with space separation and it merges into one string. Then there is a for loop, which is basically this restart function. I think once again, let me just open that monitor. Sorry, forgot to define port. Monitor. Yeah. Um. Okay. It's not printing. Maybe if I'll restart, then it should print. Yeah. Then it shuts down most likely. Okay. So what it does, it's printing hello world, then some printing, then restarting in 10 seconds. So if I go to the code, it's printing hello world, then it's printing bunch of things, then it's printing this, restarting this, and here we can see the same thing. This is ESP32 chip with one core, and before it completes its timer loop, then it sorry after it completes timer loop it prints restarting now, which is here, and then it does restart, which is this. Then some of the bootloader prints, then again here the main file. Before that it's calling app main, you can see here, which is the function here. Great. I think that is it. I'll just stop this for now. That is for the video. Next time we'll see this include in details, which might give us info about this function and this macros and probably this chip info feature variable.